Hello and welcome to the December update from the TauNet team. You'll hear from me, Fola, and so it's on to Karim for his overview from the development team.
Thank you, Fola, and welcome everyone to the Tau development team update for the month of December of 2024. As you all know, we had an alpha release of the Tau language in mid-November, and since then we've had 7 issues reported on our GitHub. I'm happy to report that as of today, all of those issues that were reported on GitHub have been resolved by the team. But internally, we have our own bug tracking system where we're tracking over 65 issues of varying severity. And since the release, we resolved 45 of those issues, 12 of which were very high severity and 18 were of medium severity, and there were 15 feature requests as well. And we currently have a backlog of about 20 known issues that we're working on. Tomasz resolved around 10 issues this month. On the parser side, he added support for testing of other grammars and made some minor interface fixes to the parser, such as inlining of the root node and disambiguating by picking the shortest span, which resolved several issues. On the Taulang side, Tomasz resolved some grammar issues and that were related to negation and conjunction. He also improved error handling and is currently refactoring input and output type definitions from the REPL and down into the Tau language. David resolved around 15 issues this month, many of which were very critical. The most important fixes were made in the solver, where he was able to address several reported issues all at once by adding a way to propagate and preserve the type information throughout all Boolean algebra operations. He fixed an issue in the splitter related to the traversal of the parse trees. He fixed the types of inputs and outputs so they match the expected Boolean algebra. In the REPL, David also fixed several errors related to reporting messages in the run command and made several improvements to the solve command. He then optimized the min-term iterator using a new algorithm from Ohad. Finally, he reorganized the testing infrastructure and moved all regression and integration tests into one group and added a test coverage build to double check the test coverage that results from all of our tests. David has also been keeping an eye on the community issues that were reported, and in particular, he merged the pull request from PT7K related to documentation, and this allowed capital T and capital F as variable names and Boolean formulas as shown in an issue that was also reported by PT7K. Lucca as well has resolved many issues this month, about 20 issues throughout all of Tau. He made improvements to the execution interface for the run command in the REPL. He corrected the execution of specifications during the initial positions in recurring relations, and he added initial temporal simplification rules during normalization. Finally, he's currently found, actually he just told me this morning, found the resolution for the issue of determinism in the execution of Tau programs. So that's one of the major issues that were discovered. Umar, on his side, has wrapped up the implementation of the parse trees that he's been working on for a long time. He dedicated most of the efforts this month to evaluating its performance and fine-tuning the garbage collection scheme. And last but not least, Andrei has made very good progress on the Tau blockchain implementation with lots of help and input from Ohad. He's been translating some core classical blockchain functionality into Tau language specifications. In addition, he continued supporting the web development team by resolving various bugs and access issues. He also introduced caching services to improve performance. And he finally also developed an automated tool for migrating Telegram groups, preserving their history, and paving the way for enhanced community management. That's it for the development team this month. Back to you, Fola.
Awesome. Awesome. Thank you so much, Karim. And I'll pass it over to David for his update this month.
Thank you, Fola. Hi, everyone. This month I've been working in several tasks regarding improvements. I have improved the minter iterator in order to reduce the amount of work following an idea from Ohad. The idea is essentially to collapse the search and use the first result that we get from the iterator. That's useful in solving in the solver mostly. I have also refactored the testing infrastructure to move regression tests to unit and integration tests. The problem here was that to properly do regression tests, we need some infrastructure from what we have in the unit and integration testing. One possibility was to extract that into a separate files, but moving regression tests into unit integration testing was more straightforward. I have fixed the types of the output so they match the expected Boolean algebra. Previously, the output were just tau formulas instead of the underlying Boolean algebra element. Now they are just plain Boolean algebra elements of the proper type. I have added a coverage pill to easily check the test coverage we have. The idea is to have a map of the source code parts that are poorly tested and so that we could provide more tests in those parts. And in the future, I think that it will be interesting to have also a heat map of the key changes so we could identify the more difficult parts in our code. More or less, we have an idea, but having, let's say, an analytic result about it would be nice also. Apart from that, I have removed the callbacks from the grammar, the code, and the test cases. That was something that in the past we were using the callbacks, and they were an important part of the code. But after the changes that I have done in the creation of nodes and hooking, let's say, simplification rules into the creation of the nodes, they are, let's say, redundant, so we could remove all that. And apart from that, I have been adding a way to propagate types through Boolean algebra operations. The last month, I add the typing for 0 and 1, and with this, let's say, propagation of types, what I'm doing is just to propagate all the information about types that we could have from the input to an upper level, so that when, for example, we compute the conjunction or the disjunction of two Boolean algebra elements, if we have some type information in any of them, we propagate to the result. Regarding issues, I have fixed an issue about the splitters. It was related to the traversal of the parse tree, and now it's fixed, so no problems there. And apart from that, I have fixed several errors related to reporting. That means messages in the run command, improvements in the reporting of information in the solve command, and other minor issues. I have also been working in several fixes and improvements in the solver. mostly related to the resolution of the meter system. The meter system is the ones that we obtain from the original system, and once we resolve the mean-term system, we could resolve the original system. Okay, and also about how the solution of the mean-term system is mapped into a solution of the original system. Apart from that, I also have been keeping an eye on the issues that the community is reporting in GitHub, and also in the pull requests that we have. In particular, as Karim commented, I have merged one pull request from PT7 key related to documentation, and also I have taken a look to an issue that he reported, but at the end actually it wasn't an issue because everything was working fine. The problem was that the grammar wasn't clear enough, and we could write, let's say, formulas that were misleading. So I decided to change the grammar and to disallow, for example, uppercase T and uppercase F as variables in Boolean formulas, and that way everything, I think, is more clear now. And that's all for my month. Currently, I'm continuing improving the solver, and next I have several ideas to improve the execution time and to speed up the execution and also reduce the amount of memory that we have. But that's next, and that's all. Thank you very much.
Always a brilliant update from you, David. Thank you so much. I'll pass it over to Umar for his update next. Over to you.
Hi, team. This is the December update. Mostly, we have analyzed the effect of enabling garbage collection in the parsing phase of the earlier parser, and our goal has been to ensure the correctness, also being as precise as possible. So, various tests were run and race parameters were collected, and it turned out that the GC that is currently implemented in the master branch, that can be safely enabled, and though we might have a marginal improvements, but that's a good one step forward and can be considered as an important feature that the parsing is also doing garbage collection for unneeded items. There's some future work that already outlined, but that will be tackled later on in the next month. Yeah, thank you.
All right, fantastic. Thanks so much, Umar. I'll pass it over to you now, Lucca. Cheers.
Thank you, Fola, and hello, everyone. So this month, I've been working mostly on updating the execution interface. So in the initial release, we, for example, were querying all inputs, even if the inputs were not needed for some execution step anymore. Now we only query inputs which are needed. Furthermore, if a formula talks about a certain look back, so for example, if you talk about t and t minus 3, so that's two different time points, that would be a look back of 3. We had no way to execute at step 0, then at step 1, so we had to start basically at this look back time step, and I added first I envisioned a method on how to actually start at step 0 for each formula, and then how to correctly resolve the outputs for all the inputs on those in this initial segment. Furthermore, we also complete outputs in a way that never makes the specification unsatisfiable. So when, for example, you do define an output in the specification, but then due to some input, this output gets simplified away, we still choose values for this output in a consistent way, so that we have one consecutive output stream for each time point. Then, due to an issue we initially realized right before the release in our semantics of the formalism of tau, we disabled the conjunction of always statements and therefore also the disjunction of sometimes statements. Since then, we have resolved the semantical mistake, and I have worked on implementing the joining of always statements, and this full solution is still to do. So the system is correct in itself, but a certain capability that we want to add back is not present at the moment. Then I also added during normalization simplification rules for temporal, for the, let's say, the temporal layer. So previously the normalizer wasn't able to simplify always and sometimes statements without the help of the satisfiability algorithm. Now there's an initial support, for example, for always statements to simplify sometimes statements. Yeah, it's an initial step. Some rules are also still missing. They are planned up next. Yes, and then in general, I have helped a lot in fixing bugs all across the system, improvements for the usability, as I said, especially the execution interface, and also feature updates and feature polishing within the system for an overall better run experience of specifications. And along those lines, the current task is about determinism of our commands, because previously it was possible that the same command with the same input resulted in different outputs, which is due to the fact that we weren't using a deterministic ordering, but the ordering of elements in certain data structures dependent on the, let's say, time point of creation of this object. And so I have been working on a way to resolve this such that we have determinism in the sense that whenever we input something into the command, we get the same output. And this is the task I'm currently wrapping up. Thank you so much for listening, and I'll pass it back to Fola.
Thank you very much, Lucca. That was amazing. Thanks so much. I'll now pass it over to Andrei for his update this month. Over to you, Andrei.
As we approach the end of the year, I'd like to share a brief update on my progress over the past months. I've been diligently working on implementing Tau blockchain, focusing primarily on translating traditional programming models into Tau language perspective. It's a complex task, but with each breakthrough, we are getting closer to create a complete operational system that supports our vision for Tau. Also, I lent a hand to our web development team, fixing bugs, resolving access issues, implementing caching services for better performance, and so on. Also, I've created a complex Telegram group management system that allows to migrate groups, transform groups, and save group history. This setting a stage for a much better community experience in the coming year. So, I wish you a joyful holiday season, and I wish you a prosperous new year. Looking forward to share more updates with you in the coming year. Bye.
All right. And last but not least, over to you, Ohad.
Yeah, basically continuing the same stuff like last month, working with Professor Franconi on aspects of knowledge representation and control natural language, and with Professor Paris on the scaling functions for the sake of compilation of TAO programs and network specification language. Also, general enhancements of the TAO language for the future, as well as testing the TAO language reporting bugs to the team, and some help with the marketing efforts. Yeah, that's basically all.
All right, I want to say a massive thank you to all of you for being such a supportive community. We wouldn't be here without you. And thank you again for such a supportive year. Have a fantastic and Merry Christmas if you celebrate Christmas. If not, have a fantastic happy holiday, and we'll see you in the new year. That's a massive thanks from the TAOnet team.